That School presents graphs. Let's talk about two important graphical representation of data, the bar graph and the line graph. A bar graph shows data as a set of bars, where each bar represents one type. The length or the height of a bar is determined by the numerical value of that particular type. Let's see what this means with the help of an example. A survey was done among a group of students to find out their favorite book. Draw a bar graph to represent the data. So as you can see on this table, as many as 8 students said that The Hobbit is their favorite book. Only 3 students said Macbeth is their favorite book, 2 for Emma, 4 for Hamlet, and 4 other students said their favorite book was outside this list. And here comes the bar graph for this data. The first bar represents The Hobbit. The second bar represents Macbeth. The third one represents Emma. The fourth one represents Hamlet. And the last one represents others. And you got to write down the names below each bar to indicate which bar represents what. So you should write down The Hobbit, and then Macbeth, and so on next to each bar, or let me say below each bar. And the number that you see on the top on each bar represents the number for that particular book. So we have 8 for The Hobbit, 3 for Macbeth, and so on. And like I said, the height of each bar represents the value of that particular bar. Because as many as 8 students said The Hobbit was their favorite book, you see the Hobbit bar as the largest bar or the tallest bar. Similarly, Hamlet and others are the same length because they have the same numbers. And they are, each one of them is exactly the half the height of the Hobbit bar. And this bar, the Emma bar, is the shortest because it's got the smallest number on the table. And that's how you draw a bar graph. A line graph is used to show data that usually varies with time. Take this as an example. A squirrel is weighed each week at the zoo, and the mass in kilograms is recorded in the table on the zoo chart. So we have week 0, week 1, week 2, week 3, all the way up to week 9. And the weight in kilograms, 2.1 kgs, 2.1 kgs, 2.2 kgs on the second week, 2.3 kgs on the third week, and so on. There are 3 questions we need to answer. The first one is, draw a line graph to show these data. On a graph paper, let's have the x-axis as the week number and the y-axis as the weight. So we have x, that's the number of weeks, and y, that's weight in kilograms. And we have week 0, week 1, week 2, week 3, week 4, 5, 6, 7, 8, and 9. On the y-axis, we could use a broken number line and say that we have a 2.1 here, 2.2. The number line is broken to indicate that there are numbers like 1, 1.1, 1.2, etc. between these 2 points, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and 3. And in week 0, the weight of the squirrel was 2.1 kilograms. So we have 0 and 2.1. Week 1 is 2.1 again. So we have 1 and 2.1. Week 2, 2 and 2.2. Here comes the point on the graph. 3 and 2.3. 4 and 2.4. 5 and 2.5. 6 and 2.3. So it comes down. 7 and 2.6. 8 and 2.8. And 9 and 3. That means the weight was 3 kilograms on week number 9. Our next job is to join these points using straight line segments. So here comes the line graph. Now let's look at part B. The squirrel was hungry one week. Which week was it? Why? If you look at week 5, the weight was 2.5. But on week 6, the weight falls down to 2.3 kgs, and therefore we could assume the squirrel was hungry during week 6 because the line graph tells us that its weight has fallen, which means it mustn't have eaten enough. And finally, use your graph to estimate how much the squirrel weighed at 3 weeks old. So we need to look at this 3 weeks and then find out the corresponding weight on the graph. As we can see, the squirrel weighed 2.3 kilograms at the 3 week mark. So this is 2.3 kgs and this one is 6th week. That's how you draw and interpret a line graph.